Hello and welcome to this video about determinant proofs. I'd like to show you this proof which proves that the area of a parallelogram made by two vectors in two dimensions will be given by the determinant of the matrix made by these two vectors. It's easier to see the statement of this proof in the equations than in the wording. This is a common and easy proof, but I'd like to include it out of completeness, because I'd like to be as complete as I can in this series, but I'd like to show it in a way that has good and colourful graphics and neat writing, and I hope to contribute to its publication on the internet. So now to prove it, we're required to show that the area is given by this equation, which is the determinant of this matrix. It's also helpful to draw this diagram. This proof is similar to Pythagoras' theorem, because it uses a similar picture and calculates the area of the parallelogram by subtracting the smaller areas of triangles and rectangles away from the total area of the large rectangle. We can see the two vectors v1 and v2 and how they create these shapes in the picture. So now to calculate the areas that we need, we'll firstly calculate the area of the total or large rectangle in this case. We can read off its sides and write them in the equation. And expanding the brackets gives us this expression. Now we need to calculate the areas of the two small rectangles added together. And we can simplify this expression to be this. Now we have to get the areas of all the triangles covered in green. And they give us this amount of area in terms of the entries of these vectors. I'll just scroll everything up the screen to make more room. Now to find the area of the parallelogram that I gave a reddish colour that's not properly red, we have to subtract the areas of all these small rectangles and triangles from the larger whole rectangle. And I'm putting it into an absolute value function so that it won't give us a negative value for this area. So now I'll substitute all of these areas into this equation. And 4 of these values will cancel out. And then we can add these two values together to give us this value. We can get the negative of this value because it's an absolute value function, which will give us the positive value of this expression. So we've proven this theorem now, but I'd like to complete it a bit more. I'll just scroll up the screen here to make some more room. Now we can write in that the area of the parallelogram is equal to the absolute value of the determinant of this matrix that we were trying to prove. I'd like to finish this proof like this, with the area being equal to the positive value of the determinant. So I hope that you've found this video to be helpful and educational. Please click like and subscribe if you did. Feel free to write anything helpful in the comments and to share this video. And thanks a lot for watching.